we have Captain's Log, and we have David and Ryan here to share all their knowledge with you. Again, as I've been doing, I'll pin things in your channel in track 2, and if there's time at the end, I'll ask them, but if not, it'll make it very easy for you to go back. So thank you both for joining, and I'll turn it over to you.
All right, thanks, Heather. Thanks, everyone. Let's see, it's our slide. There we go. Awesome. So thanks everyone for joining us virtually. Glad that we could still do this. A little different than usual when we're hanging out in Texas in the heat. So hopefully everyone is in the comfort of their air conditioning. And good morning, good afternoon, good evening, wherever you are. Super excited to be here. As Heather mentioned, this is Dave and Ryan. Going to be going through a Captain's Log. Take your application log analysis from Starfleet to Star Fleek at the SANS DFIR Summit. So Ryan can go ahead and say hi.
Hi everyone, my name is Ryan Tomsick. I'm a senior consultant on the Mandiant IR team. My background is as a SOC analyst and threat hunter in different SOC environments in the public and private sectors, heavily leveraging Splunk.
Awesome, thanks Ryan. My name is Dave Panny. I'm a manager at Mandiant on the incident response and forensics team. I have a background in doing, for the purpose of this talk, at least log analysis, focusing a lot on Excel and grep and Python scripts and text, and probably the bad way to do log analysis, but it's been a lot of fun. Also, more importantly, Ryan and I are co-creators of the organization DFUR. So we'll talk about that. This is a dog and feline urgent response. We're probably the longest standing organization in the pet healthcare and wellness industry. Not only do we take care of dogs and felines, we also take care of forensic gators and all kinds of other animals and wildlife that you may run into. But we have an application that veterinarians use to process their records, make appointments, order care, take care of their patients. Pets and wildlife use DFUR to make appointments, pay their bills, see Labrador Retriever test results, all kinds of good labs. Insurance companies will use DFUR to receive and pay claims to veterinarians. They'll reimburse patients for whatever. They'll take care of all those costs on the DFUR application. And as of start date 74005.8, we are the official veterinary and pet wellness service of Starfleet, which we're pretty excited about. And not only do Ryan and I have this very important job of running and founding the DFUR organization, we also, due to our day jobs, we hang out on the security team. And recently, we took a look at the log sources that we were trying to use in case we needed them for investigations. And wow, we had a ton of problems identified. So many problems, we can't even talk about them. But we'll focus in on the highest level ones that we want to take a look at. Up first, we looked at some logs that had some incomplete data sources. You would think that the log would be recording this activity or this field in the activity. Wrong, wasn't there. Then we saw that certain logs were being ingested into our centralized log platform, and they were being parsed wrong. There were JSON issues, the field names were wrong, all kinds of random issues that made looking at these aggregated logs, which was supposed to be helpful, made them actually quite annoying. The DFIR application, as mentioned, has been around for quite some time. And with that, right, the developers are making updates, pushing new code, changing things. And sure enough, there were a whole bunch of application updates. They changed the way logging works. No one told us about it. We never looked at them. We never figured it out. So the application updates broke some of our logs. We took a look at some log sources that were coming in from servers and systems around the world, around the Starfleet universe, I guess. And they were in all kinds of time zones. Some were UTC, some were Eastern time, some had no time zone, and we have no idea what time zone they were in. So that's another issue we ran into. While we were doing these tests, we tried to export, for example, an hour's worth of logs from a week ago. It took like 2 days to export just the log data. So that was really frustrating for us and something we wanted to fix. And pretty much our worst offender was anytime we tried to figure out where on the internet any of this activity came from, all the source IP addresses were 10.10.10. whatever, because we had a load balancer or a proxy masking all of the traffic coming in. So that was really frustrating. And there are some things that we tried to focus on to be better going forward. So in terms of, our logs were pretty terrible, but also we talked to the security team, and the analysis was also not so great. There was a lot of inconsistency. Everyone was doing analysis their own way. Some looked at the text logs, parsed them with the Python script they made to use one time, spent a bunch of time on. Others were ingesting logs into Elasticsearch and trying to query them that way. There was no consistency, there was no repeatable process, and it was just a recipe for failure. With all those logs we mentioned, all the updates, there was also no documentation, right? So we would see a log field and we wouldn't know exactly what it meant. Was it a username? Was it a patient name? Was it a veterinarian's name? We don't know what's going on here. And we kind of boiled it down and we figured out that a lot of this happened was because the application's logs were designed to troubleshoot the application by the development team so they can make updates and make sure patients get good care, but they weren't necessarily designed for investigating. And our security team wasn't involved with that, which led to these analysis problems. Oh, no. Sorry about that. So as a quick example, I'm sure a lot of people in the audience have seen logs that look similar to this. So on the left is an example of a Tomcat error log, right? You're looking through web logs, maybe someone's exploiting your stuff, and this was the log we looked at. And it's multi-line, so you can't really grep and get the full context because you're gonna, if you hit a search term in one of those exception blocks, you're gonna miss the timestamp, you're gonna miss the username, etc., like that. And it's ugly. It's hard to look at. It's hard to do much with other than tediously manually read them. On the right side is what is pretty much just a super common export from a log analysis platform, right? Everyone's probably run into the situation if they've exported logs from their log platform. We certainly did here at DFIR. We said we need some log data from that week ago for an hour's worth of timeframes. And we got back an Excel worksheet with hundreds of columns, and they were all split out. Some were useful, some were not. We started with A, went to BC to DZ to FU, and there were just all kinds of column numbers and letters, and it was too much data. How could anyone possibly deal with this? And some of the other text logs we looked at have an example at the bottom. These are some examples of the worst case offenders of timestamps that Ryan and I have seen at our time at DFIR. Right, so how can you possibly sort these if you wanted to put them in Excel? They're not really alphabetic. It's a pain to parse because there's not a consistent character length because of the names of the days are in there. The timestamps are in AM and PM. So if you want to convert from PM to the military time, 24-hour time, that can be a lot of a hassle. And there's no time zones indicated in these logs. So just some examples of frustrations that we ran into that you may have seen yourself when looking at your logs. So how in the world do we get these logs up to Fleek standards? There are some more straightforward, I don't want to say quick wins, but straightforward things, right? Everything we talked about, time zones, parsing, formatting, those should be addressed for sure. Get everything into a nice timestamps into like YYYY, MM, DD, hour, minute, second, so you can sort them, you can look at them with time zones included clearly, fix those JSON parsing errors in the log centralization platform. For anything that's not centralized, let's try and get it centralized so we can do some correlation and analytics, and we'll talk about that in a bit. But those are some of the more straightforward, yes, we can or cannot do these types of approaches. One thing that requires a little bit more effort and collaboration with the development team is trying to figure out what logs do we even want for an investigation in these application logs? What's useful, what's not, and how does that relate to the security mission we have as part of the InfoSec team at DFIR? So we're going to talk about this with the concept of threat modeling. So at DFIR, what types of threats do we face at our organization? Do our competitors and colleagues face? And how might those attacks happen? How would they work? What would they do? What would they go after? What type of data would they access? And then if those threats and attacks did happen, what kind of log data would you like to have? What questions would we be required to answer due to regulations, to tell our lawyers, to tell our board members, our shareholders, the public, right? This information is going to be needed as part of an investigation. And it would be really hard to just say, sorry, our logs were trashed. We couldn't tell you these even if we wanted to. So that's kind of how we stepped back and figure out what's the point of even having logs for this application for an investigation? So what we identified for our specific application is a couple different threat vectors that we wanted to try to simulate and model. Most of them were related to an account takeover. So if you know, a kitty or a puppy or a veterinarian or an insurance provider had their account taken over either as a result of a credential stuffing campaign, which are all the rage these days. I'm sure lots of people are running into those brute force attacks, or one-off, they got phished and then someone logged on. Phish can also be treated at DFIR, by the way. So phishing attacks are very common. Bring your fish into DFIR. But anyway, these account takeover attacks, you can bring them in and do a lot of damage if you have your account taken over. For example, you can have your bank account modified, so a payment or a claim or reimbursement might go to the wrong place. Your pet health information, your pet identifying information might get accessed. That would be a major HIPAA violation, so we don't want any of that because there'd be fines and regulations to deal with. And worst case, right, someone could have their health treatment modified or interrupted. You could cancel someone's appointment. A veterinarian could log on and change a dose of a prescription. You know, you don't want to apply too little or too much flea or tick prevention. That would be really bad either way. And back to the finance side, right? Reimbursement claims, payments, HSA accounts, things like that. And also, probably the last threat modeling technique that we saw was if a veterinarian would abuse the healthcare system and, for example, overprescribe narcotics such as catnip. We don't want any of that being facilitated through DFIR. I clicked, there we go. So how do we figure out what's lacking and what we need to improve on? Probably the best way is to review, you know, your current log setup, and we did this. We tried to export the logs, we tried to search through them, we tried to correlate and format, and there were a lot of annoying steps that we identified along the way where it wasn't formatted properly. We wish there was a session ID to map a log on to a data access log, for example, and the exporting took too long. All these things we could only discover were real problems by simulating an investigation. Because the logs should have the answers to all the questions you would need to answer. So let's say we do this exercise, right? We simulate this investigation. What's next for DFIR? What do we want to do with our logs? Well, first up is to make sure they're configured properly on the application. They'll be stored locally, and that will be a goldmine for investigators to have on the local application servers. A couple limitations, though, are that the investigator has to know which system to log on to get those local logs. What accounts do they use? Are they protected? Do they have to check them out of PAM solution? And how long are those logs going to be retained for? Kind of the best practice approach might be to centralize those logs and bring them to a log aggregation and analysis platform. Ryan's going to talk about that in a second, because you can do a lot. You can have detection functionality, alerting, monitoring, but usually the biggest reason I think that we are struggling with that at DFIR is it's a lot of costs, right? Everyone has to deal with costs, and we want to be mindful of that. But if you can get these logs into your analysis platform, you can make your logs work for you. You don't have to do the work and comb through your logs. You can have your logs tell you what you want to know with a little bit of development effort up front. So for example, we mentioned alerting. Just alert anytime a log hits a certain piece of criteria. Hard to do that with local logging. Some of the things we like to do are visualize any type of information you want to see. You want to see Cred stuffing attacks? Make a visualization of logon attempts over time. You'll clearly see when things are way off of their baseline. One of the neatest things that Ryan's going to run through are creating easy to follow investigation workflows that you can document, create playbooks for, and then any analyst can say, we have this account takeover scenario. Here are the steps I go to. Here's the dashboard I look at. Here are the correlations I want to check in on. So you can do really a ton if you sink some dev time in up front and get these logs ingested properly. Some of the neat visualizations that we've seen and we've worked on: maps, graphs, tables. I love a good heat map. And really, they kind of give you a sense for what's going on without having to scroll really fast and hope your eye catches something after 700,000 lines of log data. So those are kind of things that we work through at DFIR. Now Ryan's going to take it away.
Let's see, do I have the ability to modify the slides or work the presentation?
Ryan, it says I'm still controlling the screen. So I'm not sure if Heather or Corrigan can switch. Oh.
There you go, give that a try.
You good, Ryan?
Yeah, let me get the timing. Okay,
Cool.
Great. All right, so for anyone who's not familiar with Splunk, it's a log aggregation and analysis platform with pretty broad application across IT and security. It's also like a kitchen where its usefulness is, related to the amount of time and resources that you invest into it. And sometimes you can still burn the turkey. So when we're dropped into an active response scenario where Splunk's deployed, we're typically only given basic web access to a Splunk search head. And we really don't have the time to create advanced visualizations and use fancy things like Splunk.js. So everything that we create and all the dashboards that I'm going to be showing in the upcoming slides were created using simple XML, leveraging dynamic tokens and also drill down actions that automatically open up a new dashboard and then populate that token data. So the underlying data of the demo is authentication login activity and also database transactions that are recorded based on the user actions within the DFIR application. And we also have database lookup type commands that provide linkages between different data elements, such as the number of users or the users who are assigned to a particular organization. So it's Monday morning. I'm a DFIR analyst. I make my pour over coffee and I grab my Red Bull Chaser. I'm logging into the Splunk dashboard that shows all the modern analytics that were pre-built for me. That provide those fancy, configurations to allow me to open up new dashboards with the token values. Since all of our, customer base on the provider side is based in the United States, I may be interested in seeing which users are logging in from, non-US based IP addresses. I'm also interested in looking at users who are logging in from more than one state, which might indicate the use of a VPN server or anonymizer service. I'm also interested in any users that are requesting, username reminders or password resets, because that could kind of be the canary in the coal mine for a potential account takeover. Now, all of our providers generally follow a 9 to 5 work schedule. So I may want to look for anyone who's logging in, either very late at night or very early in the morning. And as far as potential password attack activity, I'm interested in seeing, looking at it from a user-specific point of view, in case there's, a botnet being leveraged that's attempting to brute force an account, from multiple IP addresses. So these two little fields up here give us the ability to establish thresholds for, failed attempts or successful attempts. And we can also focus on the portal, whether it's the provider or the patient portal. Now, taking a look at another angle of detecting potential password attack activity, we're also looking at IP addresses per calendar day, and we're enriching this table with, the geolocation information for the IP address and also the autonomous system information. We're looking at the, user agent and also including some different metrics on, the type of failure that occurred with the account, whether it was related to invalid accounts or bad passwords. And we're also leveraging the Haversing function to show any accounts that show anomalous activity between sequential logins based on the IP addresses, the source IP addresses of the authentication. And we're also looking at any users who are logging in from multiple autonomous system names. Most of our providers, they use some type of ISP that provides business level services or support. So to see someone logging in from a VPN would be a little anomalous for us. As far as organization analytics, what we're looking for is any user who's logging in from a source IP address that's inconsistent with the mailing address of the entity that they're assigned to. And we're also doing a similar check for any organizations, at the time that they're being registered. We're performing the same check to determine if the mailing state that's provided when the organization is registered matches up with the source IP address of the user who's registering it. And we also leverage custom Python scripts to interact with public APIs. They perform external lookups. So here at DFIR, what we did was we created a custom Python script that leverages an external lookup, and it compares the NPES data from the HHS database that's available publicly. It pulls it down and compares it to the information that's provided for an organization at the time it's registered, whether compares the organization name, the entity, city, the state, so on and so forth. And this helps us detect any fraudulent organizations that are being registered. We built some user analytics that help us detect some anomalous user activity. For example, we had an account takeover incident where the attacker was performing these repeated actions over and over again, where they would perform a username reminder and then a password reset, and then they would add a bank account and register it with the insurance provider, all in a very short period of time. So we created this analytic that leverages a transaction command that helps us to cluster that activity together and see where may be occurring in our environment. And then finally, we have access to the American Bankers Association registration key for banking account routing numbers. So that helps us compare the state or the region associated with an account number to the provider's state or location, determine if they're inconsistent. And then finally, we have a tab for watch lists if we want to track or elevate the visibility of certain organizations or user accounts or IP addresses. So we have a separate tab here for more focused monitoring. All right, so here we are. It's later on a Monday morning. I'm going to be grinding up another 23 grams of Guji Ethiopia coffee beans, and I get that notification from our customer service team. They say that one of the providers hasn't been receiving claims payments, and they logged into their account and they verified that the banking information is just not correct, and they just don't know what happened. So they're asking us to look into it. So I open up a new dashboard, and it's the user activity enrichment dashboard. And what this does is it pulls in information from our user database. It provides things like the email address, some timestamps associated with the account metadata, and it also shows the entities that are associated with this particular user account. So in this case, we can see that it's assigned to an entity called Barcheology Associates, which is a speech therapy provider. So scrolling down, we want to look at the remote access analytics of this particular user account over the past week or so. And we can see that there was a username reminder and a password reset for this account happening on June 29th from a 103 IP address based in Indonesia. And then shortly thereafter, we saw the user login, or the user account being used to log in from that IP address. We also see a little hit on this haversine distance function. But with what Scotty tells me about beaming people, I think that this haversine function is going to become pretty useless. So we're going to shift over to the another tab that shows the timeline of the user activity. So I want to see any actions that were performed by the user while they were logged in from the 103. So I'm going to click on it, which is going to automatically filter our timeline table. And we see a couple user actions being performed, such as the user email account being changed. If we click on bank account, this will set another token that'll help us focus on any bank account actions that were performed by the user while they were logged in from the 103 IP address. So we see that 2 bank accounts were added while the user was authenticated from that IP. So shifting back over to the original tab, looking at the user summary, we want to look at the bank accounts that were added. And we see that these 2 bank accounts were associated with this particular entity ID. So we're going to click on the entity ID. And this is going to automatically open up a new dashboard for organization enrichment, which provides the same type of lookup where it pulls in from the organization database, gives us the users who are assigned to that organization, And it also shows us the assigned bank accounts to that entity where there's a flag that looks for a state match based on the routing number that's provided. So this looks like it's an account takeover where the attacker may have access to the user's primary email address. All right, it's later on in the afternoon. We're reaching for our third Diet Coke, and we get another notification. There are provider and patient users who are reporting accounts being locked out. They have no awareness of the activities, so we need to look into some potential password attack activity for these accounts. So we're going to go back to our main monitoring dashboard, and we're going to look at some of we see 5 IP addresses that are associated with potential password attack activity. Based on the user agents, we see some looks like it could be a password spade toolkit, something anomalous that's very short, user agent Mozilla 5.0. And we see that these attacks are having some level of success. So a lot of them are failing, but we see a couple successful authentications from these IP addresses. So what we're going to do is we're going to click on this bottom IP address, which is going to shift us over to a new dashboard. So we're going to build enrichment around an IP address. And in the top panels, we see some metadata associated with the IP address, some geolocation information, autonomous system name. Over on the right, if any users had logged in from this IP address and performed some type of action within the application associated with an entity, that's where we would see it. And then the timeline below, we see as far as the activity timeline for this IP address, we see a high number of failed authentication attempts, so 3,000, and then 6 successful authentication attempts, all occurring on July 1st. So we're going to scroll down and we're going to look at the remote access analytics. And in the top 2 panels, we have the ability to set tokens again, whether it's based on the username or the user agent. And we can also select the successful authentication, so we can focus on the accounts that we need to reset. So at this point, we see 3 accounts that had been successfully authenticated from this IP address, and we will want to reset those passwords, look at our WAF configuration, and probably reconsider that MFA project. All right, we're home after a long day, and we're reaching for the scotch, and we hear that familiar email chime that tells us it's time to make it a double. So we get a notification from an insurance provider who says that there's some suspicious activity associated with an organization. The users associated with this organization are performing a high number of failed health record lookups of patient information that's retained by the insurance provider. So we're going to shift back to our organization enrichment dashboard, and we're going to search for that entity ID that was provided by the insurance provider. And we can see already it's pretty suspicious. I mean, the entity name is Catitude. There are 3 users that are assigned to this organization, all with a Gmail address. And the NPES information is inconsistent as far as what they provided at the time of registration and based on the data that we pulled back from the NPES database with our external lookup. So as I said, they're all, their primary email accounts are all Gmail based. They're logging in from all across the world. And we can see about a 50% success rate, fail rate for the health record lookups that they're performing. As far as the heat map, you can see that it kind of follows a pattern of a 9 to 5 during the week. So it could be an indication of some organized activity. So what we're going to do is we're going to click on one of the usernames and shift back to the user activity enrichment tab. And we can see that this particular user, that staff 1, is associated with 2 entity IDs. So one is the suspicious entity that we were originally investigating. And then the second one is this other legitimate looking entity, which had the NPES information that matched. So I think that that's pretty interesting. And scrolling down, we see some notable application actions that were performed by this vet staff account, where they had registered the organization and then added 2 additional accounts and assigned them to the entity. So what this looks like is potentially the legitimate organization outsourced some function or services to a third party, who then leveraged that previous organization's information to create a new account, a new entity, and then perform some fraudulent activity. So just kind of a recap of all the different pivoting concepts that DFIR uses. This shows that you want to be able to hook up your data elements so that you can pivot seamlessly in like a click button approach. And anytime you investigate new activity, you should backstop that with a new analytic in your detection and monitoring platform or dashboard. So I know some of these scenarios may not be totally relevant to your organization or industry, but hopefully it kind of gets you thinking about ways that your application could be targeted, ways that you could leverage the logs, whether or not you have any gap in visibility in your existing logging approach. So just to leave you with some kind of top 5 logging recommendations, ensure that the X forwarded for field is enabled so you can create useful detection analytics and investigative pivots. Also make sure everything is logged into the same time zone so that your timeline lines up nicely when you sort it. Record session IDs for authenticated users so you can quickly scope the actions that they perform in an application. And also make sure that you test your data export and archive log restoration processes. I mean, the worst time to find a surprise bottleneck is when you're in the middle of an incident response. And then also make sure that you're recording successful and failed events, especially for logons. Some default configurations may only be recording failed events. So if an attacker logs in with legitimate compromised credentials, you'd have no immediate way of knowing.
And then just to round it out with a couple final thoughts, right? If you can leave this talk with anything, right? Try to reflect on the log analysis you've done, you might do in the future. What do they look like? What are the capabilities you have to improve? And maybe use the demonstration that Ryan put on as an example of if you have the time and the capabilities to build out some of this functionality, maybe it's a good example of ways you can design it and click through. So hopefully everyone sees a little bit of familiarity in what we showed, or maybe not, that'd be great too.
Yeah, and create workflows that ensure everyone uses a standard investigative methodology, but don't make them so inflexible that they can't be updated with new log sources or analyst creativity. And dashboards and click button pivoting really lowers the analytic overhead and the number of browser tabs that you have to have open simultaneously, so that you're gonna have to copy and paste a query over and over and over again. And develop dashboards and documentation upfront to lower the technical barrier for junior and newer analysts to cross when performing investigations, especially when that inexperience might lead to incomplete data searching. So I guess we'll open it up for questions.
There's one that just came into the Discord, and the person is asking if the speakers have any recommendations or guidelines for creating log outputs for your own tools.
Yeah, that's a good question. So I'm definitely not well versed in logging standardizations, but if it were up to me, you'd want it to be easy to delimit if you wanted to open it in Excel, or easy to parse. So either pipe delimited or some type of delimiter or structure such as JSON, depending on what you're going to use it for. And then really you'd want to make sure you have everything you need that's relevant to your application, such as timestamp in a format that you're going to be able to read, time zone, username, session ID, source IP address, the type of activity performed, whether it was successful or failed. Those are some of the main things we look for. User agent, for example. What do you think, Ryan?
Yeah, I completely agree. Definitely ensuring that you are able to associate, IP addresses, timestamps, and user accounts and session IDs. As much information that you can include in your logging, the better, because that's ultimately the engine that helps you investigate and build detection analytics that are useful and powerful.
Great. And we have about 20 seconds left, and someone asked if you would share your XML files you use to make the dashboards. And if you want to, maybe you could even post those in your channel or your hallway, if that's a possibility.
Absolutely. I'll look into sharing them, whether it's in Discord or to GitHub through my GitHub account.
Fantastic. And thank you so much. That was hilarious. You should read track 2 and all the puns and comments. It's a good thing you turned off your Discord because it was blowing up. It was insane.